G'day guys, welcome to Teach Together Try. Today we are looking at what our learning intention is. Adding and subtracting fractions with different denominators. I know you can add and subtract fractions with the same denominator. Easy, but we're looking at adding and subtracting fractions with different denominators. Okay guys, and here's our success criteria. I guess our sums are going to look a bit like this, a quarter plus 8. We're going to have to find a common multiple for these denominators, and in this case it's going to be 8. We're going to have to convert both these fractions into fractions that have the same denominator, and like I said, we're probably going to go eighths here. And then we're going to add and subtract as per normal. So what's going to happen is this quarter is actually going to turn into 2/8, which is the same as a quarter. And then we're going to go 2/8 plus 1/8, of course, equals 3/8. And that's okay. Let's work out how all of that happened in the teaching phase. Okay, let's go. Okay, hey, how are you? Look, I know you can do this. 1/8 plus 3/8, easy, same denominator. You're going to have 4/8, which is like saying there's 4/8 of a pizza pie or something. Okay, now look, here's where it gets a bit trickier. 1/8 plus 1/3, look, they're different denominators. And you can't add together different denominators. You can only add same denominators. So we've got to convert these. We've got to convert them so they are both the same denominator. And I guess in order to do that, we're going to change them into an equivalent fraction. We're going to convert them into an equivalent fraction, which of course means equal fractions, which means they have the same value, but they just have the same denominator as well. They have the same denominator as well. So guys, to do that, to make these into equivalent fractions that have the same denominator, we've got to find a number that 8 goes into and a number that 3 goes into. Usually the lowest one is simplest. So I'm going to tell you right now, I know that 8 goes into 24. And I know that 3 goes into 24. So I'm going to change 1/8 into whatever it is out of 24, and I'm going to change 1/3 into whatever that is out of 24. And it's going to have the same value. It's still going to equal 1/8, but it's just going to be in 24ths now. Like here, it's still going to equal 1/3. It's just going to be in 24ths now. Here's how I do it. Okay, here we go. Look, to turn 8 into 24, I've got to times 8 by what? I've got to times it by 3. So, times the 8 by 3 and I got 24. Yes? Now with fractions, whatever you do to the bottom, you've got to do to the top. So I've times the bottom by 3, now I've got to times the top by 3. So that means 1 times 3 equals 3. And so to make it the same colour, 1/8 is exactly the same as 3/24. It's exactly the same. Right, so we've turned 1/8 into 3/24. Great. Now we've got to turn this third into 24ths as well. Okay, here we go. Now, how do we turn 3 into 24? What do we times by to get to 24 for 3? We times by 8. So, 3 times 8 equals 24. That bit's done. Okay, but whatever we do to the bottom, we've got to do to the top. So 1 times 8 would then equal 8. So look, our new sum is 3/24 plus 8 and 2, well sorry, that's not right. 3/24 plus 8/24. That's our new sum. Hey, and it's just the same. 1/8 is equivalent to 3/24. 1/8 is equivalent to 3/24. 1/3 is equivalent to 8/24. But you see, the denominators now are the same. Look, they're the same, so we can just plus them. It's easy now. It's easy now. And here we go. 3 24ths plus 8 24ths is, of course, 11 24ths. And that's your answer. Hey, you might be going, Mr. Burns, like this is an eighth and that's a third and your answer's in 24ths? Yeah, that's fine. Remember, we converted this into a 24th value and we converted this into a 24th value. We converted 1/8 into something out of 24 and we converted 1/3 into something out of 24. So it's fine that our answer is in 24ths. That's absolutely fine. Okay, here we are. Here's another one. Look, 6/10 take away 3/20. 6/10 take away 3/20. We can't do that. We've got to make them, they've got to have the same denominator. We've got to convert these into a number that is common. Until we do that, we cannot move forward. So we're in the together phase. I wonder, can you think of a number that 10 goes into and that 20 goes into? And I'll give you a hint, it's one of these numbers. Can you give me a number that 10 divides neatly into and that 20 divides neatly into? Okay, I hoped you might have come to the conclusion that 10 actually divides into 20, doesn't it? There's 2 10s in 20. And you might have worked out that 20 actually divides into 20 as well, right? There's 1 20 and 20. So this 10 divides nicely into 20 and this 20 divides nicely into 20. So we can actually convert both of these fractions into equivalent fractions with a denominator of 20. And once they've both got a denominator of 20, we can plus them or take them away or do all sorts of things. So remember, whatever you do to the bottom, you've got to do to the top. Whatever you do to the top, you've got to do to the bottom as well. So if we're going to change this 10 into a 20, that means we've times it by what? By 2. So that's how we made that 10 into a 20. We times it by 2. Hey, whatever we do to the bottom, we've got to do to the top. So if we make the 10 a 20, because we times it by 2, we've got to times the 6 by 2, which will give us 6 times 2 is 12. Okay, so we've done that. We've made an equivalent fraction. 6 over 10 actually is identically equal to 12 over 20. It's the same value. Hey, this one's a bit easy. What did we do to this 20 to get it to 20? Well, we times it by 1, Mr. Burns. It's not a problem. Hey, what did we do to this? Well, whatever you do to the bottom, you got to do to the top, don't you? So if we times the bottom by 1, yes, then we've got to times the top by 1. Hey, it just stays the same, doesn't it? But we can do the sum now. Look, 12 over 20 take away 3 over 20. And the answer is, well, 12 pizza pieces take away 3 pizza pieces is 9 20ths. Okay? And there's your answer. Let's do one. Well, actually, we've done one together, sort of. I'm going to give you one to do all by yourself. Hello, guys. Here we are. 2/5 plus 1/4. All by yourself. I'll give you some clues. The denominators are different. You must convert 2/5 into a number with a denominator. The denominators are different. You must change these fractions, both of them, so they both have the same denominator. Cannot be different. So this cannot remain the same. I don't think this can remain the same. Your question is, what number does 5 go into that 4 goes into as well? I'm going to stop. Maybe you want to go and have a look at the other ones that I've shown you before. Have a go, see if you can convert this and these fractions into 2 fractions with the same denominator. Okay? Okay, I hope you paused me because we're back now. I hope that you paused me because we are back now. And I hope that you went like this. I hope you went, right, 5... what does 5 go into, and what does 4 go into that's equal? That's a common multiple, and I hope you worked out that 5 goes into actually 20, doesn't it? And 4 actually goes into 20 as well. They both go into the number 20. So in fact, you've got to times 5 by 4 to get that to 20. So whatever you do to the bottom, you got to do to the top. So 2 by 4 equals 8. So 2/5 is the same as 8/20. It's exactly the same. Looks different, but value-wise it's exactly the same. Okay, so over here, hey, how did we get from 4 to 20? Got to times it by 5. So whatever you do to the bottom, you got to do to the top. So 1 times 5 equals 5. So 1/4 is equivalent to 5/20. Okay, so now it's 8/20 plus 5/20, which would be 13/20. Okay guys, this has been Teach Together Try. We've been looking at how we add and subtract fractions that do not have common denominators, and we've actually had to make them common denominators through converting them. Okay, I hope this has been helpful. See you later.